what we're going to be looking at is we're looking at inverse trig function derivatives. So first of all, we need to talk about what are some of the first inverse trig functions out here. So normally we would have y equals, and then we would say inverse of sine of x. Now this is going to be kind of difficult to do because we technically do not know what the derivative of the inverse sine of x. We do know what the inverse of, we do know what the derivative of sine of x, right, which is cosine of x. So what we can do is we can rewrite this equation so that it will be x equals sine of y. And just to kind of give you an explanation of what's actually happening here is, right, this is the actual graph itself. They also ask us about possibly restricting something here in terms of the range, because remember, when we're talking about writing the inverse of things, right, this is technically not a function, even though it is a y equals. So because does it pass the vertical line test? It doesn't. So what we can do here is we can restrict the domain such that it does actually give us a function, and that it does give it in relationship to some portion of this. So I can restrict the range. So I'm going to restrict the range from here to here. Because if I try to do it any other time within the origin, right, there's no other values. If I try and restrict it from the 0 to the pi, right, there's still that section that we end up having two y values for one x value. So that's not going to be a good spot. So we end up picking negative pi over 2 and pi over 2. There are some hints to kind of help you with the restrictions. They normally end up having a capital sign with a negative 1 of x, which means that that's the restricted version of the inverse function. But going back to this equation right here. So if I do the derivative of this with respect to x, of x equals sine of y. I can say the derivative of x with respect to x, which is just going to be 1, and then the derivative of sine is going to be cosine of y times, and then the derivative of y, which is going to be dy dx. Okay. So this is actually fairly easy to do, right? To get dy dx by itself, we're going to get 1 over cosine of y equals dy dx. Now here comes kind of the trick that comes along with this. We know sine squared x, or in this case, what I'll do is I'll say sine squared y plus cosine squared y equals 1, right? That's one of our trig identities. So what I can do here is I can reorganize this to put in terms of just cosine of y. So I'm going to write this as cosine squared y equals 1 minus sine squared y. And square root both sides. And then I get cosine squared y, well, cosine of y equals plus or minus square root of 1 minus sine squared y. Well, since we restricted the domain, and we're also talking about a portion of, in a sense, the slope, right, of this graph, right? I have these two versions, and I have these two versions because of how the restriction ends up tying up the trig. It does get kind of confusing, but for the most part, if I'm restricting it to negative pi over 2 to pi over 2, I can see that each tangent line that is going to form here is all going to be positive. So we're actually going to remove that negative version. So we're only really concerned with square root of 1 minus sine squared. So I'm going to replace this value right here with cosine of y. So I'm going to say 1 over 1 minus sine squared y as a square root is equal to dy dx. Now, yet again, that still doesn't get us to solve it in terms of x, right? So we have dy dx, right? But I still have that y there. Well, is there a way that I could replace this y with something? Or maybe if I go back out to the front, I know sine of y is equal to x. So I'm going to replace that with 1 over square root of 1 minus x squared is equal to dy dx. So, long story short, y equals the inverse sine of x with a restriction on the domain, or excuse me, on the range, saying that it is going to be from negative pi over 2 to pi over 2. When I'm saying that up, the derivative of this, so dy dx, is going to be equal to 1 over square root of 1 minus x squared. And that is going to be your answer.